Hello friends.
Show that the vectors A, B and C are mutually perpendicular and the vector A is 2i plus 3j plus 6k. Vector B is 3i minus 6j plus 2k and vector C is 6i plus 2j minus 3k. हे तिन्ही वेक्टर्स हे त्यांच्या रेक्टँग्युलर कंपोनंट्समध्ये आपल्याला दिलेले आहेत. आपल्याला हे प्रूव्ह करायचं आहे की ऑल दीज आर म्युच्युअली परपेंडिक्युलर, म्हणजेच A परपेंडिक्युलर टू B और B परपेंडिक्युलर टू C और C परपेंडिक्युलर टू A. म्हणजे तिघही वेक्टर्स जसे हे तीन बोट all the three axes x y z axis हे तिघही एकमेकांना परपेंडिक्युलर असतात. This is perpendicular to this, this is perpendicular to this, this is perpendicular to this. So similarly we have to show that the three vectors A, B, C are perpendicular to each other. Now we know that when two vectors are perpendicular to each other, their scalar product or the dot product is 0. म्हणजे if vector and if Q is a vector and if P is perpendicular to vector Q, then P dot Q equal to 0. म्हणजे जेव्हा ते दोन वेक्टर्स एकमेकांना परपेंडिक्युलर असतात तेव्हा त्यांचा डॉट प्रोडक्ट हा 0 असतो. नाव म्हणजेच बट वी नो P dot Q is equal to Px Qx plus Py Qy plus Pz Qz. So this dot product, this should be equal to 0 if the two vectors are perpendicular. Now we will discuss about the vectors A and B. So vector A dot vector B. So what is the x component is 2. Ax is 2 and Bx is 3. So 2 into 3, that is equal to 6. So this will be 6. This is 3 into 6, that is minus 18. And this is 6 into 2, that is 12 plus 12. So 6 minus 18 plus 12, this is equal to 0. Next, B. We have to show B dot C is equal to Bx is 3, By is 6, Bz is 2. Cx is 6, Cy is 2, Cz is minus 3. So, B dot C is again Bx Cx like Px Qx. So, 3 into 6. So, 3 into 6, that is 18. Minus 6 into 2, that is minus 12. And 2 into 3, 2 into minus 3, that is minus 6. So 18 minus 12 minus 6, again this is equal to 0. So B dot C is also equal to 0. Now we go for the A dot C. So A is 2, Ax is 2, Ay is 3, Az is 6 and Cx is 6, Cy is 2 and Cz is minus 3. So, we have 2 into 6, that is 12. 3 into 2, that is equal to 6. And 6 into minus 3, that is equal to minus 18. So, we get again A dot C is equal to 0. So, in this way, when we have multiplied the x component of both the vectors, y component of both the vectors and z component of both the vectors, we have got it as 0. So, A dot B equal to 0. Since A dot B equal to B dot C is equal to A dot C is all equal to 0. म्हणजे सगळेच 0 आहेत. A dot B 0 आहे, B dot C 0 आहे, A dot C 0 आहे. म्हणजे ह्याचा अर्थ काय होतो? जर त्यांचे डॉट प्रॉडक्ट हे 0 आहे, म्हणजेच ह्याचा अर्थ A is perpendicular to B, A dot B 0 आहे म्हणजेच काय? A perpendicular to B. B dot C 0 आहे म्हणजे काय? B perpendicular to C. आणि A dot C 0 आहे म्हणजे C perpendicular to A. So we have completed this problem. Hello friends. Today we are going to start the third chapter, that is motion in a plane.
Without option, the chapter is for 6 marks, and with option, the chapter is for 8 marks. Remember.
Now, motion of objects म्हणजे एखादा ऑब्जेक्ट मूव्ह होतो. So there are 3 types of motion when an object is in motion. So the motion in one dimension म्हणजे सपोजिंग हा पेन आहे आणि हा पेन असा स्ट्रेट लाईनमध्ये मूव्ह होतो आहे. सो ही जी मोशन आहे ही वन डायमेन्शनमध्ये आहे किंवा रेक्टिलिनियर मोशनमध्ये आहे किंवा स्ट्रेट लाईन मोशनमध्ये आहे. राईट. सो this motion is one dimension. But when an object, the object is here and it is moving on this plane, on this board, so this type of motion is two-dimensional motion in which it is moving in two dimension. The third is the motion in three dimension. That is the motion in the space. So this is the object and it is moving in this space, in this three dimension it is moving, and hence the motion of this object is called as the motion in space. It is three-dimensional motion. Initially we are going to discuss the rectilinear motion, that is motion in a straight line or motion in one dimension. We are going to discuss some definitions. So the first is about the displacement. Displace. Now, supposing an object is at time t1. t1 या क्षणाला एक ऑब्जेक्ट x1 या डिस्टन्सवर आहे and after the object is moving in a straight line. ऑब्जेक्ट कसा मूव्ह होतोय स्ट्रेट लाईन मध्ये, तो इथून इथपर्यंत पोहोचला. आता t2 या टाइमवर जेव्हा तो ऑब्जेक्ट x2 या डिस्टन्सवर आलेला आहे, त्याची डिस्प्लेसमेंट झालेली आहे आणि तो x2 या पोझिशनवर आलेला आहे. एक्स ॲक्सिस आहे ही, दिस इज द एक्स ॲक्सिस, दिस इज x1 पॉइंट अँड दिस इज x2 पॉइंट. So the displacement of the object is delta x, that is equal to x2 minus x1. So the change in position of the object at from time t1 to time t2 is the displacement delta x. Now the direction of displacement is along the positive x-axis. But if this same particle would have moved by the same magnitude here, it would have moved in the straight line along the y direction. Then the displacement, the magnitude of displacement, magnitude of delta x will be the same. But the direction of displacement will be along the y-axis now. Here the direction is along the x-axis. When the particle displaced in y direction, the direction will be along the y-axis. The magnitude of the displacement may be the same, but the direction of the displacement is different. Hence, the displacement is different. So, when the object is moving from here to here along the x-axis, the displacement, and when the object is moving along the y-axis, the displacements are different because the direction of the displacement are different. So, to sum up, the displacement of the object within the time interval from t1 to t2 is the difference between the position vector of the object. Its direction is given along the line of motion. The next definition is the path length. The path length is the actual distance travelled by the object during its motion. That is, supposing आपण एक ऑब्जेक्ट घेतलेला आहे आणि हा ऑब्जेक्ट ए पासून बी पर्यंत गेला, मग त्याची पाथ लेंथ किती झाली तर 2 मीटर्स. बट तोच ऑब्जेक्ट जर या डायरेक्ट ए पासून बी पर्यंत असा न जाता, सो इट इज मूव्हिंग इन दिस डायरेक्शन, देन it is moving in this direction, then the path length is 3 meter. Now, hence the path length is the actual distance travelled by the object. Similarly here, supposing this is an object here, it moves from this point A to this point B. So it has travelled up till the point B. Now, from point B, it has again come to point C, which is, supposing if this is in meter, which is at 2 meters from the origin, 0, 0. So, the distance, though the distance travelled, so the path length is 3 plus 1, 4. So, though the displacement of the particle is only 2 meter, so the displacement of the particle is 2 meter, but path length is 3 plus 1, 4, that is 4 meter. But remember that the displacement is a vector quantity and it requires direction. But the path length is not a vector quantity. It is a scalar quantity and we do not give the direction when we are giving the path length. The next point which we are going to discuss is about the average velocity. So, the average velocity is defined as the displacement of the body in the given time interval. Now, supposing a particle is at point x1 when time t equal to 0, and after the time lapses and after 1 minute, the particle now arrives at point x2. So, the average velocity, according to the definition of the average velocity, V average is x2 minus x1, or vector x2 minus vector x1 upon t2 minus t1. So, this is 4 minus 2 upon 1 minus 0. But here, see here, I have not given the arrow mark because I am giving here only the scalar quantity. Here, I am giving only the magnitude of the average velocity, which is 2 meters per minute. Now, the direction of this velocity should also be given because average velocity is a vector quantity and its direction is along the direction of the displacement. So, the direction of displacement is along the positive x-axis. So, we have to write here V average, or V average, vector V average is equal to 2I, I cap, meters per minute. So, this is the average velocity of the object. The next is the average speed. Average speed, V average, is the path length, the ratio of the path length to the time interval. That is, now supposing this is a particle is at point x1 at time t equal to 0. x1 is 2 meter and after 1 minute the particle travels from x1 to x2, that is, it comes to 4 meters in 1 minute. So, the average speed, that is V average, is x2 minus x1 upon t2 minus t1, that is 4 minus 2 upon 1 minus 0, that is
2 meters per minute.
Is the average speed. Now here, we have not discussed about the direction. We have not given here arrow marks because the speed, average speed, is a scalar quantity and it does not have, direction is not considered. One more thing. Now, supposing this is the particle is at point x1. It has travelled from x1 to x4. So, it has come from point A to point B in 1 minute. It has come in 1 minute. And from B, again it has travelled reverse. It has come to point C. In the next 1 minute, it has come to point C, that is point x3. So, the average velocity of the particle is the path length. Now, how much is the path length traveled? From A to B, that is 2 meter, and from B to C, that is 1 meter. So, this x3 is at 3. So, this is at 3 meters. So, this is 2 meters from here to here, and from here to here it is 1 meter. So, 2 plus 1, that is 3 meters. The particle has traveled in all. So, the path length is 3 meters. 2 plus 1, 3. And the time required from here to here, it took 1 minute. And from here to here, from B to C, it took again 1 minute. So, the time required is 2 minutes. So, it is 3 upon 2. That
1.5 meters per
is
minute.
the average speed of the particle which has moved from point A to point C. Now, similarly here, what is the average velocity? The average velocity is the displacement upon time. So, the average velocity is displacement upon time. So, the displacement is from x equal to 1 to x equal to 3, the particle has moved. From A to C, the particle has moved. So, the displacement is only 1 meter. So, displacement is 1 meter and the time required to move from A to C is 2 minutes. So, 2. So, that is equal to 0.5 meters per minute is the average velocity. So, when the particle is moving from A to B and from B to C, the average speed
1.5 meters per minute.
Similarly, when the path is the same, but when the particle has moved from A to B and B to C, the average velocity is
0.5 meter per minute.
because here we consider the path length. Here we consider the displacement. The path length does not require direction because it is a scalar quantity. Displacement requires direction because it is a vector quantity. So here we take the positions A and C, the initial and the final position is for the displacement. But for path length, we take the total distance traveled by the particle or the body. So here the average velocity is 0.5 meter per minute. So the path length and the average speed both are scalar quantities, and the displacement and the average velocity both are vector quantities. The next is the instantaneous velocity. As the name suggests, instant म्हणजे त्या क्षणाची velocity that is the instantaneous velocity. So it is limiting value of the average velocity along a very small time interval delta t. म्हणजे here आपण लिमिट काय मर्यादा काय देतोय टाइमला की टाइम शुड बी व्हेरी व्हेरी स्मॉल म्हणजे त्या क्षणापुरतीची वेलॉसिटी टाइम शुड बी व्हेरी व्हेरी स्मॉल. सो द displacement in this very very small time. So it is we write it in the differential form in the mathematics where we have studied the differential equations, or we have studied the differentiation in the mathematics. So we can write dx by dt. So instantaneous velocity is a vector quantity. Now supposing this is a party point x equal to 0. After time 2 minutes, it comes at point x equal to 4. So its average velocity will be 4 minus 0 upon 2. That is, the distance traveled is 4 meter. The time required is 2 minutes. So 4 minus 0 upon 2 is 2 meters per minute is the average velocity of the object. Now, if the object comes at point A and from A it moves to point B, the distance is very very short, that is delta x. So the distance is very very short, that is delta x, and it moves in very very short time delta t. So, v, the distance is very small, that is 0.2 meters. And it moves in time, moving in 0.2 minutes. So, 0.2 upon 0.2, that is 1 meter per minute, is the velocity at that particular instant. इथे या क्षणाला velocity किती आहे? 1 meter per minute. पण as a whole, as an average, 1 meter per minute velocity आहे का? तर नाही. As an average, the velocity is 2 meter per minute. So, this is the instantaneous velocity and this is the average velocity. So, we are going to consider the instantaneous speed. The instantaneous speed of an object about a given instant of time. It is the limiting value of the average speed of the object when the interval taken is very small. It is limiting, it is nearly tending to 0. So, the limit is, आपण टाइमला लिमिट कशी दिली आहे? टाइम इज टेंडिंग टू 0. म्हणजे टाइम 0 नाही आहे. 0 असेल तर मग व्हेलॉसिटी सांगताच येणार नाही. बट टाइम इज नॉट 0. द टाइम इज व्हेरी स्मॉल. व्हेरी शॉर्ट टाईमसाठी आपण त्याची स्पीड काढतोय. इथे आपण ॲरो मार्क दिलेला नाही आहे, म्हणून आपण ही काय निघणार आहे? dx अपॉन dt ही त्याची स्पीड असणार आहे. सो व्हेरी शॉर्ट टाईमसाठी आपण ही स्पीड काढलेली आहे. यालाच आपण डिफरन्शियल फॉर्ममध्ये dx बाय dt पण लिहितो. सो दिस इज द इन्स्टंटेनियस स्पीड, म्हणजे त्या क्षणापुरती, त्या क्षणाला काय स्पीड आहे त्या ऑब्जेक्टची. दॅट इज द इन्स्टंटेनियस स्पीड. इट इज अ स्केलर क्वांटिटी. Up to what we have studied, we sum up the displacement, the average velocity and the instantaneous velocity. All these are vector quantities. They require direction, and the path length, the average speed and the instantaneous speed are all scalar quantities. They do not require direction. Now, the displacement, the unit of displacement, the SI unit of displacement is meters and CGS unit is centimeters. The dimension of displacement is L to the power 1, M to the power 0, T to the power 0. The velocity, the SI unit of velocity is meters per second and the CGS unit of velocity is centimeters per second. The dimension of the average velocity is L to the power 1, M to the power 0 and T to the power minus 1. Similarly, for instantaneous velocity also, the SI unit for instantaneous velocity is meters per second, centimeters per second, and the dimension is L to the power 1, M to the power 0 and T to the power minus 1. Similarly, for path length, the SI unit is the same as that of the displacement, that is meters, and CGS unit is centimeters, and dimension is same as that of the displacement. For average speed, the SI unit of the average speed is also meters per second, CGS unit is centimeters per second, and the dimensions are according to the average velocity. And for the instantaneous speed, the SI unit is meters per second, the CGS unit is centimeters per second, and the dimensions are according to the dimensions of the instantaneous velocity. The difference between here and here is these displacement, average velocity and instantaneous velocity require direction, and because they are vector quantity, the direction of the displacement, average velocity and the instantaneous velocity is along the direction of their motion. That is, the direction of displacement is along the direction of motion of the body. The direction of average velocity is along the direction of the displacement of the body, or the direction of the instantaneous velocity is along the direction of the displacement of the body. Here we have discussed some terms related to the rectilinear motion. Thank you.